Hello and welcome to another part of my Godot racing game tutorial. In this video we are going to look at changing our game to a VR game. We'll eventually make this optional, but for now we're purely going to look at the basic conversion. Before we get into things, I'm currently in Europe visiting my parents. Sometime during the flight over, I welcomed my 1000th subscriber. Thanks all, I'm really grateful for all you guys joining in. For our tutorial today, I am using the OpenVR plugin for Godot, but the code should be nearly identical when using the Oculus plugin. Do note that we're using Godot 3.1, and the plugins in the asset library only work with Godot 3.0. You must compile the plugin from source in order to use them with Godot 3.1. Once 3.1 is officially released, we will update the plugins in the asset library. I have already placed the plugin in the add-ons folder for our project. We start by saving our current camera node into a subscene in a folder structure I've created. We'll reuse that at a later time. We'll remove our camera node for now. We then add an AR/VR origin and AR/VR camera node to our scene, but we add these to our car node. This ensures that our origin point moves with our car. We now move our AR/VR origin node to be roughly where we want the player's head to be. You'll notice our camera points backwards. We rotate our origin point around. Our camera will be tracked by the VR system, so any positioning and rotation will be overwritten. We'll save our AR/VR origin node as a subscene, so later on we can more easily swap it out. We need to create a script for our AR/VR origin node to house the logic specific to our VR mode. Now we add a couple of lines of code into the ready function of our script. We search for our OpenVR interface by calling findInterface. We check if we found an interface and initialize it if we have. We turn on the AR/VR mode on our main viewport. And finally we turn HDR off. This is still needed when using the OpenVR plugin. Now we're ready to test what we have so far. Oh, we're really high up. Our positional tracking will have us either sitting on a chair or standing up and measures our head's position in relation to the ground. We'll need to deal with that first. We start with our project settings. We are going to use one of the buttons on our controller to recenter our view. Good practice is to create an action for this. Actions allow you to assign multiple inputs that will result in the same action and gives you the ability to change this easily. We thus create an action called Center HMD and assign the B button of our first controller to this. We're not going to make this a direct action, but will require our player to hold the button down for a second or two. So we'll handle this in our process function. I could also do this with a timer, but this felt easier. Either solution is fine. We simply check if our new Center HMD action has the pressed status. If so, we'll decrease our reset timer. Once it gets to 0 or below, we call the Center on HMD function of the AR/VR server. This function takes two parameters. The first tells Godot how much of the orientation it should ignore. We tell Godot to keep the tilt, which results in the direction in which we are looking being ignored, but we keep whether we are looking up or down. The second tells Godot whether we want to keep the height. We set this to false. The end result of calling this function is that our camera will be looking forward out of our car at the position we want our head to be. If our action is not pressed, we reset our timer. Now we can see that after holding down the B button for 2 seconds, our camera position changes and is nicely where we expect it to be. Now we can start driving and turn our head to see where we are going. Now you may wonder why we don't call Center on HMD automatically when our game starts, but we have two very important reasons for this. The first is that depending on your headset, tracking data may take a few frames to become accurate. We may center our HMD too early. The second is that many players may still be in the process of putting their HMD on when the game starts. They may have had to remove their headset to set up the game. While it is a lot of fun, I can also exit the car and break the game logic. So we really want to nudge the player to keep their heads roughly in the area we want it to be, and a common technique is to black out the screen. We can do some funky stuff like mixing different viewports and whatnot. I will demonstrate a far simpler and low cost technique for this. We'll add a mesh instance node to our AR/VR origin node and create a sphere mesh for this node. We'll make the sphere nice and large. It is at this time I realized I had forgotten to set the far plane on our AR/VR camera, so I quickly fixed that. Now we need to create a shader material and a shader. Editing our shader, we start with defining the type of shader we want, which is a spatial shader, and we set 2 render modes. First, unshaded, because we don't want to apply lighting, and we disable our culling. This last setting quickly turns our entire screen white, as our sphere encompasses our entire view. When we switch to our main scene, we see that our sphere whites out the background of the scene. We start with defining an alpha uniform that we can set from outside. We'll use this later on to fade our sphere in and out. Next, we'll write a very simple vertex shader in which we're going to modify our projection matrix. This will overwrite the z value that we would normally calculate and fix it to the near plane. Note that I'm making a mistake in the last line that I will rectify at the end. Now when we look at the main scene, it is all white. Our entire scene is blanked out. We don't want a white screen. We want to show something useful for the user, so let's continue. I'm adding a fragment shader now, where I'm setting the color to black and outputting our alpha input as the alpha output. Yes, shaders are case sensitive, so we can do this. We'll add a uniform at the top so we can input an image. And we drag an image I prepared earlier into the new image shader parameter slot, so we have an image. I'm going to copy our UV input into a variable. We'll be adding some modifications to this in a minute. Then we use the texture function to read our texture value at a given UV. This wraps our texture all the way around the sphere. We want it much smaller to make it readable. We're going to apply some factors to our UV to tile the texture around the sphere. Because we're inside of our sphere, we also need to make our X value negative. And we need to subtract an additional 0.5 to center the image. You'll note that the image is still far too large, which is due to the mistake I made in the projection matrix, but it is now readable. As we look around, we see the image repeated all over the sphere. We'll use an if statement here to only do a texture lookup for the tile that faces forward to our camera. I'm starting with just checking our UV's X component and returning black if we don't have our specific tile. Looking around now, you can see we only have a column of textures. Let's do the same for our UV's Y component and we end up with just the one image we want to display. Now we need some code in our VR camera script to show our sphere when the player has moved too far away. We export a variable that defines the maximum distance to our origin point we're happy with. We also define a variable to store our current alpha value in. It is very easy to calculate our distance because this is simply the length of our camera's translation vector. If this distance is greater than our max distance, we want to show our sphere. We simply increase our alpha value until it reaches 1. This will fade in our sphere. If the distance is smaller and our alpha is non-zero, we start decreasing our alpha to fade it out. Once we reach 0, we hide our sphere altogether. It was at this time I realized the mistake I made in the shader logic. I had swapped the 2 and 3 around in the last line, which caused the calculation of the W component of our projected vector to be altered instead of the Z component. Once fixed, you can see our image looks pretty decent. As always, a capture of what we're seeing in VR isn't being done justice recording it like this. but you can see our message to center the headset nicely appears on our view. Because we use a large sphere, this message is projected a fair distance away, making it comfortable to read. As soon as we've held down the B button for a bit, we end up nicely in the driver's seat. When we look around, we can see that the screen starts to fade to our message whenever we move our head too far away from our driving position. I found it far more easy to drive the car around the track in VR than on the desktop. Being able to judge how fast I'm going and being able to look into corners is really cool, even on such a simple track as this. I'll probably stick with the VR view for a little while as we add more functionality to our little race game, but the plan is to make this a mode you can choose. At this point in time, it is the choice between using the VR camera or the normal camera that will decide whether we are running this in VR. That is all I have time for today. I hope you enjoyed this video, and if you did, I would greatly appreciate a like. There will be far more content in this series, so be sure to subscribe to my channel and hit that bell notification button to be informed when a new video comes out. See you next time.